L equal to mu4 minus mu5, where this is the 10-inch and the 12-inch. So again, these add up to 1. I mean, add up to 0, a plus 1 and a minus 1. They did the comparison. Yeah, so you got your confidence interval was 0.2 plus or minus 0.628. So they said, okay, that includes 0, so therefore this L implies that the 10 and the 12 are equal. So see, in fact, you could, this Sheffey test could look just like the Tucky test, where we compared each to each other. What's the difference? Well, the difference is how you form this confidence interval. The Tucky test used that Q distribution. This Sheffey test used the F distribution. So it's just a different statistical distribution. So is one better than the other? Well, yeah, the book says that the Tucky method gives a tighter confidence interval when you want to make pairwise comparisons. So maybe it's a little tighter when you do pairwise, but for a general contrast. So if you've made some general one like that one we have with the 3 and the 5. Food here? That's okay, good. It's a good place to break. The Sheffey's generally a little more sensitive. And so what I'll do when I get back, we'll do that other one more. So what are we doing again before we, just so you know, we're coming up with different ways to find out which ones of the means were different. And the primary difference between the two ways is how they form these confidence intervals, which statistical distribution they rely on. And so that's the crux of what we're doing with the Tucky and the Sheffey method. It's necessary, I think, because otherwise you're going to have a hard time figuring out what variable. So when we get back, grab your food. When we get back, we'll do the Newman-Kuhl's and that little paper because it's kind of interesting. So yeah, see what we got to eat there, right? Let's see. And then this, we'll come back to this in a minute too. So keep that up.
I just had this guy in the middle of one of our meetings. You like sat there for a minute. Tried to click it. It's going backwards.